Let's prepare on flow through pipes. So today we are going to see about the flow through pipes. So in this fluid mechanics we will be studying as flow through pipes separately and flow through the open channel separately, because the behavior of the fluid in the pipes and the open channel will be different. So we'll be studying this as a separate chapter here. So now in this flow through pipes, the Reynolds number plays an important role. So based on the Reynolds number we can justify what the type of flow is actually occurring in the pipes. So first, what is the Reynolds number means? It is nothing but the ratio of the inertia force divided by, that is the ratio of inertia force to viscous force of a flowing fluid in a pipe. So here you can see the ratio inertia force by viscous force. So it is derived and it is formulated as rho Vd by mu. This is for circular pipes, and rho Vdh by mu. This is for non-circular pipes. So circular pipes means this rho we know its density, V is the velocity of that flow, and mu we know it is dynamic viscosity. This d will be the diameter of the pipes. Whereas in the case of this non-circular pipes, the dh, it denotes just the length. So if you are taking any plates means the length of the plate will be written there. Okay, so here for finding the dh, it is also given as 4 times the area by perimeter. You can use this formula also to substitute dh here, and r is nothing but, so this also we will be seeing in the next thing, that is hydraulic mean depth. R is equal to a by p, area by perimeter. So when you expand area and perimeter of any shape, that is rectangular or square, means you will be getting d by 4 as the value. So this is all about your Reynolds number. And the next thing is the color dye having same specific weight of water. So aniline is just an example for that. It is used to study the flow pattern. So what they will be doing is, this aniline and water has the same specific weight. Okay, so they will be mixing this aniline in the water, but it has a different color. So they will be calculating, or they will be analyzing the motion of this aniline particle in the water, so that we can study the flow pattern, whether it is laminar or turbulent, like that we can study from that. So already we have seen what is laminar and turbulent. Laminar means the particles flow in a specific direction with a specific speed. It does not disturb each other. But in turbulent, it will be moving in a zigzag manner, so it is creating like eddies will be created there. So that is only turbulent, and in between there is a stage that is called transition stage. So here this Reynolds number value is given based on these flows. When it is less than 2000, the flow is said to be laminar, and when it is 2000 to 4000, the flow is said to be transitional flow, and when it is greater than 4000, it is a turbulent flow. And this value is based on critical and upper critical, means we can define it as, when it is equal to 2000 it is critical, and if it is 2700 to 4000 means it is upper critical. And this terms comes here, that is head loss. Head loss is nothing but due to the change in the height, no, so with that we will be creating a loss here. So this is always directly proportional to the velocity of the flow. So v power n, it is directly proportional to that. Here when the flow is laminar, n is equal to 1, and when the flow is turbulent and it is a smooth pipe, means n is equal to 1.75, and it is a turbulent flow and it is a rough pipe, means n is equal to 2. So this formula is also will help you in competitive exams. The next thing we are going to study is the losses in pipes. So now we have just studied what is pipes and what is the flow of that water or fluid particle moving in the pipe experiences. That is what we categorize the fluids with respect to Reynolds number. So now there will be losses in the pipes, because whatever energy it is produced at the starting will not be reached at the end. So there will be some losses faced by the water or liquid particle moving inside the pipe. So that we are going to see now. So the first one is major loss due to friction. So due to friction means it's just the resistance offered by the fluid particle and the pipe material between any two matters. Okay, so here the fluid and pipe material is taken. So when the friction is caused between these two, there will be a loss happening. So that is the major loss. That is mostly the loss will be due to this reason only. So we tell it as major loss. Then we can see about the minor losses. Minor losses will be due to change in velocity and change in transition. So when this change in velocity and transition comes, when the sudden expansion or sudden contraction, the cross section changes, no, so at that times this transitions and velocity changes will be coming. So due to this reason there will be a minor loss created in the fluid particle. And the next third one is laws of fluid friction for laminar flow, and fourth one will be seeing the law of fluid friction for turbulent flow. So again this friction only, it's differently given for laminar and turbulent. So first, the friction that is for laminar flow means here this frictional resistance is directly proportional to the velocity of the flow, area of the surface and the temperature variation also. And then it does not is proportional to the pressure and the nature of surface. And the next one is the law of fluid friction for turbulent flow. Here the frictional resistance is directly proportional to the velocity of flow, fluid density, temperature variation, surface area and nature of surface also, and it is not directly proportional to the pressure. The next thing we are going to see is the frictional loss of head. So this is the major loss we have seen, no? So how to calculate this frictional loss? So it is denoted as HF, that is the frictional loss, which is equal to FLV square by 2GD. So this is the general formula given. Okay, so here this F means it is the friction factor, or sometimes we will be substituting the coefficient of friction also. So in the question, if they have given friction factor means you have to use this formula. If in the question they have given the coefficient of friction, that is F dash, means then the formula will be 4F dash B square LV square, like that it will be changing. Okay, so that is the change you have to make with the friction factor and coefficient of friction. And we know the continuity equation A1 V1 will be equal to A2 V2, and then we also know Bernoulli's equation. So this is applied in the pipes also, so they have given here. So P by rho G plus V1 square by 2G plus Z1 will be equal to the same thing, plus in addition to that head loss will be given, that is HF, that is the head loss is added here due to this frictional loss. And then impulse momentum, we know that force is equal to mass into acceleration. And the next thing is the laminar flow based on this frictional force, that is the frictional factor, is calculated. If you take here, F will be equal to 64 by Re and F dash will be equal to 16 by Re. Okay, so this will be asked in the question. So how they will be asking means, they will be giving you this is the flow, that is a laminar flow is occurring, and you have to find the friction factor, like that they will be giving. So you should not worry, they have not given Re value, Reynolds number value, like that. They have already studied for laminar flow, it is 2000, no? So you have to just substitute that value 2000 here. So when you substitute 2000, you will be getting 64 by 2000. So you will be getting some value of 0.0 something. So that will be your friction factor for that flow. So if they have given the Reynolds number accurately means you can substitute that. If they have not given, and if they are generally asking laminar or turbulent means, you can just substitute the values 2000 and 4000 respectively and find the answer for friction factor and also the coefficient of friction. The next thing is for turbulent flow. So here this is F is equal to 0.316 by Re power 1 by 4. So turbulent means you have to use this formula only. And the next one is the minor loss. So we have just seen the major loss due to the friction, no? So in minor losses there are various categories of that, so we will be seeing one by one. And note this, if it is more than 5% of major loss, then it should be added up. Otherwise it is not necessary to add this losses in the total calculation of anything which is regarded to the pipes. Okay, so when this becomes 5% of major loss, when it's exceeding that, you have to add this also. So the first one I have taken is sudden expansion. So you can see the diagram here. A small tube is given and a pipe is given and a pipe is expanding. So this is called as sudden expansion. So if this is the case means the head loss, that is HL, will be equal to V1 minus V2. So this is nothing but the velocity in the first section and velocity in the second section. The whole square divided by 2G, or another formula is V1 square by 2G into A1 by A2 minus 1 the whole square. So this is another formula. I can use both. And the second one is sudden contraction. So this is just the reverse. It is contracting from a larger size to smaller size. So here it is Vc minus V2. Vc means nothing but the contracted velocity only, they are denoted like that, by V2 the whole square by 2g, and another formula is 0.5 V2 square by 2g. And also for this sudden contraction you can use another formula, that is V square by 2g into 1 by cc minus 1. So this 1 by cc minus 1, like this we have to write. So this cc is nothing but the coefficient of contraction. So this we have seen already, no? So you can use that formula also for sudden contraction. And the third one we are going to see is the entrance of pipe. So when a pipe is starting from a tank, so this will be your entrance for that pipe. So at that point the entrance of this fluid is taken and there the loss will be happening. So this will be equal to 0.5 V square by 2g. So only one velocity is taken here. And the next one is the exit of the pipe. So exit means when it is leaving the pipe, it is V square by 2g alone. And bends or pipe fitting. So when a pipe is taken, a bends will be kept in some places, no? So there also some losses will be happening. So that to find that, the formula is k V square by 2g. K is nothing but the bend constant. So they'll be giving the value here. So this is all about your 5 different categories of minor losses. So with this lecture we have seen the flow through pipes, Reynolds number, Darcy's law, that is the Darcy's law is only the friction factor formula, no? So that is only Darcy's friction factor, and then that is the major loss, and also 5 different categories of minor losses. Thank you, and keep watching for the next lecture on hydraulic gradient line.